Okay, so I wanted to have a quick run through the activation energy lab report. There's something a little weird about this lab report, and that's the first thing you need to note is that the time is in seconds and that both of your concentrations are in molarity. So uppercase M there for molarity. So as long as you realize that, and then you're good to go. Okay, so the first part is that we have to figure out what the order of this reaction is. So it's a decomposition reaction, which just means that our reactant here, we only have one of them, is just going to break apart into, multiple things. So whenever we have just one reactant, we can use integrated rate laws to determine the order of the reaction. So what we're going to do is we're going to make 3 plots using the data at the lower temperature, where we plot time on the x-axis, and then we're just going to plot straight up concentration, log of the concentration, and 1 on the concentration. And that's going to tell us whether we have 0, first, or second order in our rate law. So whatever of these plots is linear, that's going to allow us to identify the order of the reaction. So all I did was I just copied this data over into Excel, and then I made those graphs. So I'll show you what that looks like. So here is the data copied over into Excel, and in my first column, which is going to be my x's, I've got the time, and then I've got my 2 concentrations in the adjacent columns. So what I want to do now is I'm only looking at the 298 K data here. I'm going to select my X's and my Y's there, and then I'm going to insert, and I always use a scatter plot for this, and I make a plot of the concentration against time for the 298 set of data. And I can see pretty quickly that it isn't a linear plot. So I know immediately that this guy is not 0 order. So I'm just going to put in here that this is concentration of NO2, and then the units for that are going to be molarity. All right. So we know that it is not. We know that it's not first order. So what I need to 0 order. Sorry. What I need to do now is I want to calculate the log of the concentration of NO2, and I'm going to do this at 298 and see what happens. So you can just do this by hand if you want, but I'm going to speed things up. I'm just going to go equals ln, and then I do parentheses, and I want that value there. Okay, and then when I click on the little thing here, double click on that one, and it'll autofill, and it'll take the log of everything that's in column B. So I just kind of sped that up a little bit. Okay, so now I select my X's, and then I hold down the control button and I select my Y's, and I do insert, and I go over here, scatter, and again I see that it is in a straight line. It's got a curve there, isn't it? So I go over to the plus here, put in some axes titles, and that's going to be time in seconds. We go, and then this one's going to be concentration of NO2, and it'll be molarity. Okay, so I've got my titles there, and again, it's not linear. So it's not first order in this case. So let's move on and make another one. I'm going to do 1 on the concentration of NO2 at 298. It's my next data, my next column. So I'm going to do the same thing here. I'm just going to put the little formula in, equals 1 divide that there, and then I'll copy that down, and then I select my time and my X's, hold down control, select my Y's, insert, scatter plot, And this one, what do you know? It's a straight line. Okay, so again, I want to include my axes titles. I always want to do that. So axes titles, click on that. That's going to be time in units of seconds. And this one here is going to be 1 on the concentration. Oh, I just realized an error I made there. 1 on the concentration of NO2, and that's going to be have units of 1 on molarity. And the error I guess I noticed that I made was my axis title there. I forgot to include the log, didn't I? So we'll have to go in there and we'll just put it up in here. It's going to be log of the concentration of NO2. And just in case you don't know, anything that has anything you're taking a log of doesn't actually have units. Alright, so that's pretty good. I think I got one janky set of parentheses up there, but I can't be bothered changing it. So clearly it is second order because that is the one that is linear. So now I want a trend line in there. So I just right click on my data, add trend line, and I want to get the slope and the intercept. So I'm going to display the equation on the chart. And so what I know is that my reaction, my decomposition, is second order, and when I plot 1 on concentration against time, I know that the slope of that plot will be equal to the rate constant. So we'll keep that in mind. So now, when it comes time to figure out when it comes time to think about the higher temperature, what I know is that the rate constant should be bigger because it is at a higher temperature. But what I also know is that the order is not going to change. It's still going to be second order. So what that means for me is that I don't have to do all 3 plots. I only have to do the 1 on the concentration plot. All right, so that makes things a little easier. So when I do the next one, I'm just going to do just copy that over, and I'm going to change that to 328. I don't have to do all 3 plots. I just have to do the one for the inverse, right? So there it is. Okay. Boom. And so then now I select time. That's my X's. I hold down Control. I select my Y's. Insert. And I select scatter plot. And sure enough, there it is. There's my scatter plot. And when I right click on this and add the trend line, I then ask it to display the equation, and what I'm looking for is that the slope is a lot bigger than what I had at 298. So remember that as the temperature increases, the rate constant will get bigger, and because it's an exponential dependence, a small change in the temperature results in a big change in the rate constant. So at 298, the rate constant was 0.09, and then at 328, it was 0.7. So it definitely changed by more than a factor of 7. So I feel good about that. So yeah, it's second order, and I have 2 rate constants at 2 temperatures. So I'll go back to my my lab report now, and here we are. We can start asking it, right? So it says, using the data for the experiment, use a graphing program such as Excel to create 3 graphs. We did that using that data. Determine which graph is most linear. It was that one. And have the graphing program generate the best fit line. We did that. Be sure to show the equation on the chart and submit it along with your report. So we've got all of that worked out, haven't we? There it is there, right? There is the linear graph, and we've got the line of best fit. We've got all of our axes, titles, and everything with our correct units. And then we've got the equation there. So that's good. Okay. So what is the order for the decomposition of NO2? And it is second order. The rate law looks like this. Rate equals K NO2 squared. Then it says, what is the value of K for this reaction. So that's just going to be the slope of our graph there. And it was 0.07. And, we should be realistic about our sig figs here. So I think 2 sig figs is fine. Now, what are going to be our units? Well, it's second order. So that's going to mean that we should have units of concentration to the -1. And then it's going to be time to the -1. So that's seconds to the -1. So you want to think about that. Okay. So now it says make a graph of the data at 328 that corresponded to the same order, because changing the temperature does not change the reaction order. So we're going to use our 1 on concentration against time again. Write the equation of the best fit line which the program created below. So that's just going to be here. Oh, sorry, that was 0.09 in the first one. Sorry, my mistake. That's just going to be this guy. So I can actually just copy that, can't I? I should go back. That was 0.09. Let's just put, there's our graph there. So it is 0.7002 times by our x, which is time, minus 2.027. And then that's what y is equal to, and our y is 1 on the concentration of NO2. So our y equals 0.7002 times by our x, which is time, minus 2.0277, and that should have been 9. There we go. So what is the value of K at 328? Well, it's going to be 0.70. I think with 2 sig figs is fine, and the units don't change because it's still second order. There we go. All right, so that should get you going. All right, that should get you going. Now it says use the data to determine the activation energy for the reaction. Show your work below. So I'll just explain how I would tackle this. We can use the 2-point form of the Arrhenius equation. And then we will be able to solve for the activation energy. Now we can do that because we've got 2 Ks at 2 different temperatures, right? 2 Ks at 2 different temperatures. So that should be pretty easy. So remember that this guy is going to give you the activation energy in joules per mole. You probably want to convert it to kilojoules per mole. So then the final question, fairly straightforward. What would be the K at 348 K? Now, obviously, the thing to recognize here is that it should be bigger than what it is at 328. And remember, we said small changes in temperature result in fairly large changes in K because it's exponentially dependent. So what we're going to do is use our 2-point form again of the Arrhenius equation. But now we have EA, and we're going to be solving for one of the Ks when we're at 348. So what do you put in for your other K2 and T2? Well, you could either put in your data for 398 or you could put in your data for 328, whatever you want. You could do it twice and average the result if you really wanted to. The important thing is that your K at the higher temperature should be even bigger again, right? So it should be bigger than what you got at 328K. So that's really all I've got for you. If you don't like using Excel as your graphing program, you can use Google Sheets, and there are many other graphing programs out there. It doesn't really matter. If you get stuck with a graphing program, Google and YouTube will probably be able to help you out pretty quickly, or you can always ask me. Okay, good luck with everything. Let me know if you have any difficulties.